are gonna fix it. They can fill out the survey, which is good. Live webinars, always fun. There's 3 questions.
They can hear the music, not the talking.
They can hear the music.
Now. Working, fixed.
You can hear me now, I believe. Yes, excellent. Well, there was a long introduction by Melissa. Thanks, Melissa, for that, where she explained what Mobicon does, and you could have seen it on the slide, so I hope you didn't miss too much. But in the meantime, I have started talking. You missed the first bit, but that's okay. I see most people are finding their way in the Mentimeter. And I see we have a lot of traffic engineers and transport planners in the audience, which is good. As you can imagine, this is kind of awkward for us not to have an audience, so it's good to know that get to know you guys a little bit and see what kind of people we have in the audience. I know not everybody has managed to fill out the first question yet, but given we only have 30 minutes, we are going to continue with the topic. If I can go to the next slide. There we go. So the 3 topics for today. The first one is Sustainable Safety 101. Obviously, this is not a full day workshop as usual, so we're going to go for a short introduction in sustainable safety, which is the Dutch version of Vision Zero. Vision Zero, or Dutch Sustainable Safety, has its origins in the 1970s when we had a similar mobility crisis that we see today. Very few cars on the road, carless Sundays because of the oil crisis in 1970, 1973. And that really showed the Dutch how things could be different. It was a change to the normal. As you can see, there's urban highways, there's connectors and arterials, and then there's rural and neighborhood streets. But today we're only going to focus, if I can click to the next slide, we're only going to focus on the arterial streets and the neighborhood streets because we do have to limit our knowledge today on the local, the urban environment. So there's 2 types of streets in the urban environment. There is an arterial. You have a problem? No sound?
No sound.
No sound. You can see me, but you can't. You can see me talking, but no sound. Yes? Yes? We're back. Okay. I hope you didn't miss too much. There's 2 types of streets in the urban environment. One is the arterial road, a 50 kilometer or 30 mile per hour speed limit, and always separated cycle tracks. Then there's the neighborhood street or the local access road where you have a more residential environment, or maybe even a main street with a 30 kilometer or 20 mile per hour speed limit. On the neighborhood streets, there's no separation between bikes and cars, and they have a very distinct design that I'll explain to you in a second. If I can go to the next slide. There we go. This is the standard design of a 50 kilometer per hour arterial street. On the left, you see from the CROW guide, the standard ingredients of a street. Basically what you would call a complete street in other contexts. So it's separated cycleways, an asphalt street, and that signifies this is a road where you can drive 50 kilometers per hour because you have a safe distance from bikes and pedestrians. On the right-hand side, you see an example of this from one of our clients, Canmore, in Alberta, Canada, where they also have taken this on board. You can see this is a very different design from this, which is a local access road, a 30 kilometer per hour street where you mix bikes and pedestrians, and sometimes even bikes, pedestrians, and cars, sometimes all together in one space, sometimes with a separate footpath. This road is generally constructed in brick with no separated cycle facilities. Because it's a different texture and a different look and feel, drivers will immediately recognize the street design and adjust their speed accordingly. That's the beauty of sustainable safety as a national guideline. So this design is translated all over the country. Every single residential street should be constructed in brick. Then, what happens if two of these types of streets meet? How do we keep them safe at intersections, which are the most important places where the most crashes happen? So if two access roads meet, one of the brick roads, the local slow streets, we rely on people interacting with each other. We don't rely on signage, we don't rely on traffic lights, we rely on people making eye contact. And one of the preambles that you have to rely on human contact is that the speed must be low enough so people can respond to other humans. And that means that the speed limit obviously is 30 kilometers per hour. The road is constructed in brick, which has a different texture and different feel from asphalt. And at the intersection, it's generally raised, so you know as soon as it gets raised, you know that there's an intersection coming, and you can expect other road users. As you can see in this image, no signage at all, no markings even, just highlighting that there's a raised table. Conditions are yield to the right. If an access road meets a distributor or an arterial road, a slightly larger version, the arterial will get right-of-way, but we don't default to traffic lights. It'll just be a give way for the access road to the arterial road. And one of the key features that we use in this way is the driveway configuration, as we call it. The road is constructed, or the side street is constructed as if it were a driveway to a private property, which means that the cars coming out or going into that side street have to yield to all traffic on the arterial street, including pedestrians and bicycles. So pedestrians and bicycles get a continuous cycleway and a footway, as you can see highlighted in red and yellow in the slide, and cars have to give way to all traffic. Turning vehicles, you see the ramp, a very short, very steep ramp, really slows people down, slows car drivers down, and gives them the time to respond to their environment and give way to bikes and pedestrians. Then what happens if two arterial or two larger streets meet? Then it gets interesting. The default treatment for that is a roundabout in the Netherlands. I'll explain why that is in a second. If you can't fit a roundabout, for example, or if the traffic volume is too high and you want to keep it that way, then you might revert to traffic lights, but that's never the default option for two intersecting arterials. And why is that? If you remember one slide from this presentation, I want it to be this one. It's because traffic lights are proven to be the least safe intersection option. They cause, or they have the most crashes and the highest number of fatalities. Traffic lights are always a traffic management tool. They're never a safety tool. If you want to implement traffic lights, it's not because you want to make it safer, but it's because you want to keep a certain level of traffic flow going. And that's why we prioritize traffic flow over safety once you put in traffic lights. That doesn't mean they're not a good or valid tool in the toolbox, but you have to realize that it's not for safety, but it's to optimize the traffic flow. And this is research done by the Dutch Scientific Institute for Traffic Safety. The green line is the respective risk of a crash for a roundabout per number of motor vehicles per day. The red line is the same line for a four-way signalized intersection. And as you can see, if you have about 25,000 vehicles a day, the roundabout performs about 3 times better than the equivalent signalized intersection. So that's a good thing to remember. Roundabouts, if well constructed, are indeed much safer than signalized intersections. Then, the core of our today's webinar, protected intersections, or as we call them in the Netherlands, intersections, because most of them are actually protected. So we have a first question about protected intersections, just to see how aware you are of how they function, and if you have any that have been built in your community already. So there's a Mentimeter question, and you should be able to answer that now, with how many protected intersections have been built in your city to date. I'll just give you guys are about 10 seconds behind me, so I'll give you a little bit of time to catch up and see if anybody's got experience using or seeing a protected intersection. We got 9 votes, 10, there we go. It's going up. I see a lot of zeros, which is unfortunate but not surprising. Some have 1 to 5. There's a few people probably from the Netherlands, Belgium, or Germany that have 11 or more. but I see that most people live in communities without any protected intersections, which is, again, not surprising, but a little sad. You can keep voting because we'll still record the answers, but I'm going to skip ahead to the next question, which is your community that you know of planning to build a protected intersection in the city in the coming 2 years? So this is probably more of a question for the transport planners and the traffic engineers that work for a city, to see if there's anybody who's planning one of these to be built in the near future. I know there's a lot of focus on protected intersections nowadays, especially in North America, which is probably also why there's so many people watching this webinar. But as we can see, yes, most cities, or about half of you live in cities that you know of that are planning a protected intersection. About half not yet. So there's still a lot of work to be done, which is good. 60 votes. Oh, that's kind of shifting. It's good. Okay, I'm going to move ahead. We've got 100 votes. That's probably a significant sample size. I can't click the next slide. Right? Yeah. For those of you who are planning or designing a protected intersection, these are probably a few pointers of what not to do. This is an example from the town where our head office is and where I am at the moment, Delft. There's something wrong with this intersection. As you can see, it's not quite protected, but the most important thing that's going wrong here is this little waiting box for a left-turning bicycle. You can imagine a bike sitting there is fully unprotected, and any car following them will be able to, if they make a mistake, hit them and with bad outcomes. So that's definitely something you want to avoid. In Belgium, they call these murder strips at the moment, so that's a good name for them. Try to avoid this as much as you can. Don't do this. This one, an example from, I think it is Sweden. Looks pretty good. It's a pretty generous cycle lane with an advanced stop box for bikes, but yet it's not quite up to standard. You might have already spotted it, but the biggest problem is this yellow box on the right-hand side of my screen, at least. That is a left-turn waiting area for left-turning cyclists, but as you can see, the arrow behind it, it's also a straight-through lane for cars. So you can imagine what happens if the light turns green for cars going straight, but the light is still red for left-turning bicycles. Or if there's a bicycle waiting, the light changes color and the car behind it didn't see the bicycle because they were fully focused on the traffic light. They're going to go straight through them. Again, not a safe space to wait for left-turning cyclists. So also don't do that. Then, this is the thing that distinguishes the Dutch from the Danish, and this is what we like to pride ourselves in as having safer intersections than the Danes. This is an intersection from Copenhagen. As you can see, beautiful blue painting, so very clear that there's going to be a lot of bikes. Very wide, very generous bike lanes, which is good. But there's one problem. This lady waiting to turn left, is not protected at all. Any right-turning car or truck, she's going to be right in their blind spot. And might be sideswiped while the car is turning right. So again, don't do this. So if you've had some experience with protected intersections already, what would be the biggest obstacle of implementing these in your community? I see some people have already voted, which is great. So some people say not enough space. When people say there's not enough space, I always say that means you've just given too much space to cars, and you want to push too much traffic through a corridor that's actually not fit for purpose for that much traffic, and you might want to look at your network to see what else you can do. Funding is obviously a problem. It is going to be slightly more expensive, slightly more intricate to get a protected intersection funded than a normal one. And misunderstanding of operations is one that we see a lot, actually. Every time we've done a lot of these masterclasses on protected intersections, and there's always a little bit of confusion about how they work and how well they operate for bikes and pedestrians. Good voting, 107, 108 is going well. So yeah, not enough space seems to be the key theme, and I'll show you a few examples of more compact versions of protected intersections as well. Then, the three principles behind protected intersections. The first one is forgiveness. Humans are going to make mistakes while operating a vehicle, or while riding their bike, or while walking, but none of those mistakes should be fatal or should cause injury. And that's a very important one. That means you have to create some buffer space, make sure people can see each other, and we rely on each other's forgiveness to make sure that nobody dies while using the intersection. The second one is separation, and that means physical separation, but also separation in time. For example, no right turn on red, obviously for Europeans, but in a North American context, right turn on red is still permissive, and that's actually one of the key factors in pedestrian fatalities. Separation in space means that you keep vulnerable road users away from people using very heavy vehicles and trucks, for example. Redundancy is the last one, often overlooked. You'll see that a well-designed protected intersection operates just as well with or without traffic lights. That might sound strange, but if there's a power cut or lights failure, the protected intersection will still operate safely and pretty efficiently, actually. And we'll see that in the next designs. Then, this is the basic outline of a protected intersection. Probably familiar to you guys in some sense, but maybe you haven't quite figured out what all these elements mean. So I'm going to pick all of these elements apart to explain why they're important and if they can be compromised on or not. So the first important and often misconceived idea is that it's going to be bad for left-turning cyclists. Because yes, a cyclist turning left is going to have to stop potentially twice. First at the 1 to wait for the straight-through light to become green, and then at number 2 to wait for to cross over the opposing traffic lane. And that might be a little bit of extra delay, but to balance that out, the right turn is always free. There's no waiting for the right turn because you don't actually use the traffic lights at all. So that balances out. The second way to balance that out is by good signal phasing. If you would signal this clockwise, if you understand what I mean. So first the 1 will get green, followed by or pretty quickly followed by number 2 that will get green, then the actual waiting time is very limited. The Dutch also generally have very short cycle times. We like to get traffic moving quicker and use less stacking space or storage space, queuing space. That's number 1. Then the second one, making sure there's the opportunity for eye contact between drivers and cyclists. And the way we do that is by creating a bit of a buffer space. You can see where the little green car is sitting. That space should be about 1 car length long. This allows drivers that are coming and making a left turn to respond to the changing environment. So for example, if a cyclist would run a red light or a pedestrian, there's still that buffer space to respond and react to the situation without having an instant fatal or damaging ending for either party. So creating that buffer space also creates these little islands, the third very important and characteristic element of a protected intersection. So the blue is the protective island that can be as big or as little as you want. It can be just a single pole with a little circle around it. As long as it has a vertical element, it will keep the cyclist safe on the outside of that island. So that's a very important element, and that's the one thing that distinguishes a protected intersection from a non-protected intersection. Then the fourth one, the advanced stop bar. There's multiple advantages to putting the cyclist as far to the front as you can. One is that cars that will be waiting at the stop bar, they will be looking at the lights, the near side signals in the Netherlands, and they'll always have a cyclist within their field of vision. And that really heightens their awareness of cyclists being in the same intersection using the same space. Secondly, it creates some storage space for bikes. So if the light is red and somebody wants to turn right with the free right, it's still possible to pass waiting cyclists behind them, so they don't have to wait for the light to turn green before they can turn right. It also shortens the crossing distance for bikes, and that's a key one because that really helps the operation of the traffic light as well. If you can keep the signal phase for the cyclist a little bit shorter because the crossing distance is not so long, you can really optimize the traffic flow as well. So that's a win-win situation. Then the median islands, they're nice to have. They're not necessarily required. We generally have them if there's more than 3 lanes of traffic to cross. Why do we have them? It's not so you can allow a 2-stage crossing for a cyclist or a pedestrian going straight. They'll still always have to have the option of going straight in one single light phase. But if something goes wrong, if you drop your keys halfway, there's a point where you can safely stand and wait for the next cycle to come along, and there's not really an immediate danger to your life if something happens along the way. And then, for people joining us from the UK, this is a sticking point for us. Cyclists stay on the inside. We've seen designs from Manchester where cyclists are on the outside for several reasons that I'm not going to go into today. But it's for us, we find this to be safer, more predictable. Cyclists are on the inside along the roadway, so at the intersection they're also on the inside. And yes, that means a slightly bigger detour for pedestrians, but it reduces the pedestrian-bicycle conflict. Too much technical detail for this workshop, but trust me, you want to keep it predictable. That's the important factor. Then I've got a few applications of these principles, just to give you an idea about where these intersections are applied. They can be from a very large, very suburban context where you have 3, 4, 5 lanes of traffic. For example, this one, this is also in Delft. Same principles apply. You can see the corner islands, you can see cyclists on the inside. They're all bidirectional cycleways because the intersection is so huge. But the same principles apply for a large intersection or a smaller intersection. For example, this one from The Hague, quite compact, where the footprint of the intersection is actually not much bigger than the footprint of the general travel lane or the right-of-way. So you could fit this into a normal 2 or 4 lane corridor. But the same intersections again apply. You can see the islands are a little bit smaller, everything is a little bit more compact, but this is also used by large trucks, for example, because the turning radii are still in place. Another example, another T intersection now from above. This was actually transformed from a 4-way intersection to a 3-way intersection. But again, islands, one at the top you can see is very small, and then on the bottom left is much larger, even planted island on the inside. So this is a very urban context where the road was just a little bit too big and you couldn't fit a roundabout in. Then the last example from a fairly suburban town close to Rotterdam, where they had a fully protected intersection. You can see all the elements are there, so you'd say, well, that's a good outcome. But if you remember the one of the earlier slides where I said traffic lights are not the safest option, they agreed with that and they actually changed it to this. You can see the building in the top left stays in the same place, and they went from a fairly large 3-lane approach cross-section to a signalized intersection to a 1-lane approach roundabout, which operates very efficiently if you stay under 25,000 vehicles a day generally. So those were in high-speed train order my principles, and hopefully we got you a little bit of insight in how a protected intersection operates. I see we don't have any questions submitted in the Mentimeter yet. We do have questions submitted in the Mentimeter. Okay, so now we're going to field some questions live. I'm going to try and give you the best answer, but obviously this is scary. In the Netherlands, is the space within the continuous footway legally part of the road or part of the footway? That is a good question. I don't think we have a legal definition or distinction between footway and road. It's all within the public right-of-way, but it will be classified as a footway, yes. It's the same right-of-way, but it is a footway because all cars crossing it will need to yield to the pedestrians. It's also always going to be in the same, or preferably, not all cities are as good as applying this, in the same texture and the same pavement, continuous pavement, no curbs, no curb cuts, to really highlight that it is a pedestrian footway. Source of the research article about safety. I hope you're referring to the graph with the roundabouts. That is the Dutch SWOV. They have an English part of the website as well. You might be able to find it there. But it is the Dutch government working group for scientific traffic safety research. I think that's the best translation, more or less. What about rural areas? Have you got examples of secured infrastructures? I guess you're looking at secured infrastructure. I hope you're meaning protected intersections. Often in rural areas, we see that the bike network and the car network are quite separated. So there'll be great separation between cycleways and car lanes. So there will be little tunnels or bridges, so not as frequent, especially when the speeds are a bit higher. But if there is an at-grade crossing, it will most likely be a protected intersection as well, yes, even at 80 kilometers per hour speed limit, for example. Then, can protected intersections be applied to bidirectional or bidirectional cycle track connections? Yes. Do one more. We tend to, we don't prefer bidirectionals, especially if they're on one side of the street, because it creates uncertainty. It's less predictable. You don't really know where the traffic is going to come, the cycle traffic is going to come from. So that's a risk. But if the road is very large, the risk of crossing twice is probably larger than the risk of having bidirectionals on both sides, if you get what I mean. And then what's very important is that you keep the speed at the turn low and make sure that it's fully protected by traffic lights. Doesn't give you full protection, but you can do as best as you can. What happens on very steep streets? This is the Netherlands, so we don't have many of those, but it could work in the same way. There's no real obstacle for that. How expensive are protected intersections? In the Netherlands, they're very cheap because they're just intersections. So we don't pay for them out of the cycling budget because most cities don't even have a cycling budget. They will just pay for them out of general road construction budgets. The price obviously depends on where it is, how much work you have to do, but they're not an added cost because they're not seen as an additional thing. Can you talk about how pedestrians fit into the whole picture here and also about people with partial sight navigating these junctions? Yes, we get this question a lot. There is, the argument often is that because they're split, so as a pedestrian, the first section when you cross the bike lane is generally not traffic light protected. And then the second half where you cross the car lane is, that might cause some confusion. In the Netherlands, we've had these intersections for decades, so this is also part of training for partially sighted people. So there's no obstacle to implementing these from the Foundation of the Blind or any other advocacy group for partially sighted people. It's also complying with all of the Dutch accessibility standards. Pedestrians do have a slightly further path out of the way, but it's a matter of seconds, so it's not huge. When cyclists go through protected intersections, do cars have green signal as well for the straight and right turn? No, preferably not. Sometimes there's an advanced bicycle light, so they can go first, followed by a right turn for cars. Sometimes it's permissive, so you can turn right at the same time as cyclists going straight. It's not preferred, but sometimes it's allowed, but then there's always going to be a blinking indicator light for drivers. Is there any information explaining Dutch signal staging, who goes and when? Yes, I encourage you to learn Dutch to read it. It is a book about this thick. It's very complicated and for a whole new webinar, I guess. The question of liability when an accident occurs is a vital one. In Austria/Australia, it's the reverse of the Netherlands that totally affects how drivers act towards bikes at intersections. I respectfully disagree. Most Dutch drivers don't even know about assumed liability. It's definitely not something that we keep in the top of our heads while driving. The only thing that it does is when a car or driver hits a cyclist, they pay for the repair of the bicycle. It doesn't result in huge financial disbenefits to the driver, and it's definitely not a key factor. The key factor is designing safe infrastructure and not liability laws. Do you always use a different color surface material to make the distinction between pedestrian and bikes clear? Always is a big word, not always. It is in the guidance that bikeways should be red, but it is slightly more expensive. Some cities choose to use gray tiles, gray concrete slabs. There's a lot of different options. Some use black asphalt. The preference is yes, but it's not always adhered to as in every other country. There's a lot of questions, it's good. Is there a low-cost way to implement a protected intersection to retrofit an existing intersection? Yes, I would say start by pushing the curb line out. When you do that, which you can do with a cone, you just put a cone slightly closer into the intersection. You'll see that drivers will start going slowly around it, and there you can fine-tune and test how far you can push it out before people start hitting the cone. That's a very simple measure, and you can do it overnight, monitor it for a day and see how it happens, and then start using more serious solutions like concrete planter boxes, for example. Solutions for even denser environments from the ones you showed. If you don't have, I guess you're referring to less space. If you don't have more space than that, you probably should be looking at removing some car lanes. Dutch inner cities are obviously very old, medieval street patterns, very narrow streets. There you won't see many protected intersections. There we treat it differently. We rely more on give way intersections, which means that the traffic volume will need to be lower. Germans think that, oh, this is a generalization, I like it. All Germans think that the distance between the cycleway and the roadway are unsafe. What is your response? Well, our advice or our evidence shows that that's not the case. Distance between, there is a sweet spot. You shouldn't have about, I think it's between 1.5 and 2 meters of distance is unsafe, because you're giving people the expectation that there's not going to be a cycleway, and then all of a sudden there is. So it's either a car length or very little. That seems to be the sweet spot, if I have this correct. I will look that up. Do you think Manchester's new junctions will be dangerous? I knew this question was going to come. No, I don't think it'll be dangerous. I think it'll be annoying for cyclists because it becomes very wobbly. What we see in the Netherlands is a lot of people falling off their bike because they hit a curb. I think that risk is higher with a more wobbly or more detoury street or cycleway on the Manchester intersection. I think it will still be much safer than what they have currently, so it's not bad, but I think it could be better. Why is it necessary protected line in a one-lane roundabout, as you have shown before? Is it not safer to share the road? No, it is not safer to share the road. It is definitely safer to pull the cyclist and the drivers apart. The difference in kinetic energy, which is the thing that causes injury when two things collide, is just too large. To have it go safely at a reasonable speed, if you can get the speed and the volume low enough, then you can do it more safely, but it really needs to be 20, 25 kilometers an hour. How can we convince officials who don't see the need? That's a good question. It's a difficult question. You call us. I think there's a lot of evidence around this topic, and I think there's not a lot of discussion about if these things are safe. I think the discussion is about do we need to take traffic capacity away to do this safely? And that's a difficult balance, and that's, I think, where the real question is, because the question around if these things are safe is not really valid anymore. Is there a legislated standard for protected intersections? No, it's all guidance. There is the CROW publishes a guide. That's not a standard. It explicitly states it's not a standard. They want to encourage engineers to think for themselves. They just give you guidance on how things work, and they'll never give you a template saying this is what it should look like. Do pedestrians have priority in each design? Do we have different designs? We do have different designs. Amsterdam used to have a lot of zebra crossings across cycleways, so pedestrians have right-of-way, but given that cyclists tend to have more they want to keep the flow going, because stop-start is very difficult, more difficult for cyclists than for pedestrians, they started to take out the zebra crossings and give cyclist priority. I'm not a big fan, but in some instances I can see that it's more safe, especially if there's places with a lot of cyclists and a lot of pedestrians where they mix. You might have to be more pragmatic about this. 2 more questions. I see we have 26 more questions, but we're only going to do 2 because we ran out of time. How do protected intersections work with light rail infrastructure? Yes, they do. Exactly the same as with other. You would just probably have a light rail running down the middle or on the side, and generally they will have full signal priority for light rail. The trick is to make sure that cycle lanes will cross the light rail at a right angle to avoid injuries, but it's no problem at all. I love this question. Do you think there is any room for improvement even in the Netherlands? There is lots of room for improvement, especially in the Netherlands. I think we're generally, obviously, it's pretty safe for cycling here, but we have the same issues as everywhere else in the world. We have a rising number of traffic injuries and fatalities. Also, I think a lot of it is because of distracted driving. Dutch drivers are not saints. They still drive like any other driver in the world sometimes. And I think we still need to reimagine our streets on a daily basis, because we also see a lot more people cycling nowadays than a few years ago. And that means we need to readjust how much space we give to cars versus bicycles for every project that we have, basically. That was the last question. Good question to end on, I think. With that, I would also like to say that anything you see on Google Maps is not necessarily good. There's a lot of bad design still in the Netherlands that we want to reimagine or rework, but still working through that process. Then a few more things. Housekeeping messages. We are, in response to the COVID-19 crisis, we see a lot of cities that are working as quickly as they can to provide more space for people cycling and walking. We obviously encourage that a lot. If there's anybody that has a question about that, please get in touch, because we are here ready to help cities as much as they can. If you want a full emergency bike network, we will deliver that to you in a week, because otherwise, what's the point? So that's one thing that we'd like to put out there. The second item, we have a program called MobiCoach. If you like learning and you want to have basically a Dutch consultant on a hotline, we can help you with that, where we have a program where you get a number of calls per month, and you can just give us a call at any time, hopefully within daylight hours in the Netherlands, where you can ask us any question about any type of urban mobility, cycling design advice, but also any educational, cycling education, behavior change, parking. It's basically a what would the Dutch do in this situation on a quick phone call away. There's a few cities that are doing this, and it works really well, and it's very affordable and quick design. And then I'm doing another webinar, not as fancy as this. It is for the Association of Pedestrian and Bicycle Planners in the United States. It is on the planning of physical and digital infrastructure for micromobility. That doesn't just include scooters, but it also includes these scooters. That will be next Wednesday at 3 p.m. Eastern Time, or 9 p.m. Amsterdam time. And you can register via the APBP website, or for those that are members of APBP, there will be an email, or it's already in your mailbox, I think. And then, I think we like doing this. It is more effort than it might look like, but we like doing this, and I hope this was interesting for you guys as well. So we'd like to do this again, but because we have a series of topics that we can talk about for half an hour, 45 minutes, we'd like to get a gauge for what's the most interesting topic. We have a traffic calming workshop. We have a safe roundabouts workshop that we've slightly touched on today, but obviously there's a lot more to dive into. We're working on a school zones workshop, so that'll be a little bit later. Obviously micromobility is a hot topic that we can discuss, and then there's the really important topic of network planning that we'd also like, that we also can run a full workshop on. So yeah, a little bit of a gauge of what's the most interesting. I see a lot of people going for traffic calming, so that is good. I like that one. Also network planning. Nobody about roundabouts? Come on, guys, roundabouts, super interesting. I like the roundabouts one. Okay, this is going well. 82 votes. Nice. Traffic calming, I guess, is a good topic. Obviously, we'll take a little bit of time to work on that, schedule it, set up this whole studio environment again. But we will definitely get back in touch once we have a date set for that. So with that, we have reached the end. I have no idea what time it is, but I think we did quite well. Yeah? Oh, nice. So thank you for joining. I hope you enjoyed it. If your question did get answered, please feel free to get in touch via these email or Twitter addresses. You can always reach us or follow our newsletter, where every 2 weeks we publish a new blog and some interesting reads from around the web about a specific topic. And we'll hope you'll join us again next time for the webinar on maybe roundabouts, maybe traffic calming. We will survey as well to get some feedback on how this went. Please don't tell us the sound didn't work because we're aware of that. But we'd like to get some feedback on how this went and what we can improve for next time. So thanks for joining our first test. Fairly successful, a few learning points, and we'll hopefully do this again soon. So take care.